Hey all, good evening. I'm Ravikiran from Incus Technology, and I'm excited to welcome you all to our webinar on the role of AI, BIM, and digital twins in next-gen construction. Uh, we all know that the construction world is changing fast, and today we'll be talking about how these emerging technologies are helping teams work smarter, build faster, and make better decisions. So I'm very thrilled to introduce our speaker, Mr. Ajay Anto, CEO of the Inca Technology. CEO of the technical technology. Anto is a seasoned construction and leadership tech leader with 20 plus years of experience in driving digital transformation. As a chartered member of RICS, he has been leading the adoption of AI, BIM, and digital twin technologies to improve project efficiency and decision making across the built environment. So we are all excited to learn from his insights today. So please join me welcoming Mr. Ajay Anto. So we start. So feel free to drop your questions in the chat anytime. We'll take them during the Q&A session, and this session being recorded and will be shared with you after this session. And Anta sir, over to you.
Thanks, Ravi. And good evening, everyone. And thank you for joining me on this webinar today. It is my pleasure to be with you to discuss this topic, the role of AI, BIM, and digital twins in the next gen construction. A topic that's very close to my heart and which is transforming the very foundation on how we design and how we build. The convergence of artificial intelligence, building information modeling, more commonly known as BIM, and digital twins. We're talking about something that's not just changing our industry, it's redefining it. The convergence of artificial intelligence, building information modeling, and digital twins marks one of the most important shifts in the history of construction. For decades, we've described construction as traditional, slow to evolve, and paper driven. But that perception is changing. Around the world, construction is entering a digital renaissance, one that combines the power of data, automation, and intelligence. Construction, historically viewed as one of the least digitalized industries, now stands on the edge of an AI driven revolution. This revolution has been researched, discussed, and debated at various forums, and all of them agree that the construction industry is at a tipping point. The need to build faster, safer, and greener has never been greater, and the pressure to modernize has become an opportunity for all of us to leap forward. We are not talking about incremental improvement. We are talking about a fundamental shift from paper based, fragmented processes to intelligent, interconnected ecosystems. And this webinar is about understanding that transformation, how AI, BIM, and digital twins are not just tools, but the foundation of an intelligent, connected ecosystem for the built environment. So come down right to the tech evolution we've gone through so far, the process that we are going from manual to intelligent. If you think about it, the evolution of construction mirrors the evolution of human civilization from manual craftsmanship to industrial automation and now at the present time to intelligent orchestration. To appreciate where we are going, we must understand how far we've come. Our phase one, the manual era, which relied entirely on human skill. We had hand drawings, depended on field experience, manual coordination, and a lot of paperwork and documentation. Knowledge was tacit, it was stored in people's minds, not in data. Every mistake we discovered on site during the process of construction, which cost us a lot of time and cost us a lot of money. Data didn't exist. It was human intuition that drove success. And then we move on to the phase two, which was the digital era, the introduction of CAD, project management software, and digital communication. So definitely information became digital, but we still remained siloed. Coordination improved, but insights were still limited. Productivity also improved. But as I said earlier, systems still remain siloed. And therefore, we are entering now into the phase three, which is a intelligent era where artificial intelligence, IoT, cloud computing, and predictive analytics now integrate across the project lifecycle. Data is real time, decisions are proactive, data informed and automated where possible, and collaboration is no longer in a meeting room, it's global. According to a white paper by Bekinski and Statistics Canada, I will be referring to this white paper often as I go forward. Construction is a 13 trillion global sector projected to grow 50% by 2040. And yet, productivity lags global other leaders by nearly 40%. This white paper that I referred to calls this the global opportunity gap, and AI is the bridge. The opportunity lies not in more labor, but in smarter systems. AI and data sharing frameworks are key to closing that gap. Think about what happened in manufacturing. Industry 4 turned factories into data ecosystems, and construction is also following the same path. From blueprints, we are moving to brain prints, where building themselves are learning to and adapt to the environment. We are shifting from managing projects to managing intelligence, where data becomes as valuable as the buildings themselves. Now, I want to ground this evolution in a real world example, and therefore I'm taking our own journey at Incus Technology. At Incus Technology, we've seen how innovation grows step by step. We founded in 2015 with a vision to integrate intelligence and infrastructure. 2019, we won a DRDO's Dare to Dream Innovation Challenge. In 2020, we partnered with Colliers to drive digital innovation in real estate. And you can see in the last couple of years, from 2023 to 2025, we were recognized with multiple awards, including HDFC Tech Innovators Award, Best AI Startup for Infrastructure, and Fastest Growing Indian Tech Company. I don't want to dwell on the company's laurels, but I want to treat this as an example because each milestone represents not just progress, but proof that integrating AI and digital workflows isn't theory anymore. It's happening. Our journey isn't unique. It reflects a broader story. The same transformation that's reshaping construction globally is happening here in India also. We are part of a movement from fragmented operations to intelligent connected delivery. The Construction Bites report, it's a report done by the National Research Council of Canada, and it's also backed by research from Autodesk. The same report which I was referring to earlier mirrors this sentiment, stating that AI technologies are no longer experimental. They are commercially viable, and their scalability depends on leadership, not technology. The barriers, and we'll discuss some of this more as we go down into the further slides. How now our barriers are not in the technology readiness, but it is in adoption readiness. The future belongs to the innovators, those who combine technology and trust to create measurable impact. So, what is the vision of the next gen construction? What do we mean when we talk about next gen construction? It's not just about using more tools. It's about integrating intelligence at every step of the process, bringing intelligence, people, and systems together seamlessly. The four pillars of the next gen construction, if I were to name, number one, integrated intelligence. That means data connects every stage, whether we are designing, building, or operating. There has to be a seamless flow of data across design, execution, and maintenance. The second pillar, unified collaboration. And I'm not saying just collaboration. We did collaborate in the past too, but it's a unified collaboration where architects, engineers, contractors, and also owners can work in sync. Collaboration has different meanings. Is I work on something and someone works on something else and we bring it together. This is working together at the same time. It is breaking silos among architects, engineers, contractors, and owners. The third pillar, predictive management. And again, quite different. A lot of people think about maintenance and such when we talk about prediction, but this is predictive management, where AI can simulate scenarios. It can prevent issues even before they occur. So using AI, we can anticipate issues, we can anticipate delays, also, and we can address quality risks. And of course, in this day and age, nothing stops, if we don't talk about sustainability. So AI also helps us to achieve sustainable outcomes. Smart AI models can track energy, can track emissions, and resource efficiency in real time. Now just imagine a system that alerts you on a construction site 3 days earlier that there's a material shortage, which can automatically reschedule a delivery. It can update your cost projection in real time. And this does not require manual intervention. This is what we mean by predictive construction. To achieve this, there are four central enablers of transformation that have been identified. One is standardization and interoperability. That means shared data definitions. Again, this is something that I will dwell a little bit in detail as I go forward. The second is the automation. So AI is not only used for documentation and compliance, but actually to automate every process that we do. The third enabler is the knowledge synthesis across projects, learning from every project. Today, in this day and age, we are losing information from the project, once the people are transitioned out of that project. So we don't carry on the lessons learned from a previous project into the next project. There has to be a platform which enables continuous learning. And of course, the last is the predictive analytics, foresight through data. Together, they define the blueprint for intelligent construction. These form the backbone of the next generation construction, creating a learning industry where each project will improve the next. Imagine a system that can learn from every project ever built, turning collective data into collective intelligence. So let's take a look at the global momentum and where we are today. So in the current adoption scenario. So happy to say adoption is growing rapidly, but maturity varies across organizations, across countries, across geographies. But there is a momentum, and that momentum is global. So looking at the India and global trends, right, we've got around 60% of large developers in India who use BIM. Digital twins are emerging in infrastructure, real estate, and energy. Their adoption is increasing, especially for smart cities and large assets. AI-based monitoring, safety analytics are increasingly common. Especially now we have these 360-degree cameras, the drones, etc. International governments are also leading adoption because there are BIM mandates which are now policy in the UK, Singapore, Canada, UAE. Even here in India, a committee has been actually formed to provide guidelines for digital twins and BIM modeling. Another insight from the Construction Bytes workshop, 75% of the participants became more open to data sharing after understanding artificial intelligence's value. The biggest learning, trust and transparency are essential. They are not just tools. It also tells us something important. Technology adoption follows culture, not the other way around. People adopt what they trust. This is a cultural shift from treating data as proprietary to viewing it as a shared industry asset. The race is no longer about who is building cheapest. It is about who is building smartest. Let's look at some of the industry challenges regarding the adoption of intelligent tools and some of the key challenges our industry continues to face. These are issues that affect not just project performance, but also profitability, safety, and long-term asset value. The four big ones we'll discuss are cost overruns, schedule delays, disconnected workflows, rework due to poor coordination and inefficient data use. First, cost overruns and schedule delays. This is one of the most persistent problems in our industry. Studies show that over 70% of large projects experience cost overruns, sometimes exceeding 20 to 30% of their original budget. The reasons are often a mix of factors: inaccurate estimates, scope changes, supply chain issues, and unforeseen site conditions. But a deeper cause lies in the poor integration when design, procurement, and execution don't speak the same language. Ultimately, every delay impacts not just cost, right? It also impacts the reputation of the stakeholders involved. It impacts the client's trust in us, and it also impacts the future business opportunities that we may have. The second one, disconnected design site maintenance workflows. Now, in many organizations, design happens in isolation. By the time drawings reach the site, conditions may have changed, materials may differ, and teams must improvise. Then, when assets move into the operations phase, maintenance teams often have limited visibility into design, intent, or construction records. These disconnects across the life cycle, from design to site to maintenance, is creating inefficiencies, creates safety risks, and it misses optimization opportunities. The real challenge in achieving seamless information flow across all phases. Rework due to poor coordination. Rework is another major productivity killer. Industry data suggests that up to 10% of total project costs can be attributed to rework alone. Poor coordination between teams, incomplete drawings, unclear communication, or even late design changes all contribute. Imagine an electrical layout that conflicts with an HVAC drawing, or foundations that are poured, and as soon as you finish pouring, you get a revised structural drawing. Each of these lead to wasted time, wasted material, and of course also affects the morale of the people that are executing work. The modern digital tools and integrated project delivery methods can greatly reduce this, but they require a culture shift towards collaboration. Inefficient data use across the life cycle. Our industry generates massive amounts of data, from BIM models to sensor readings, maintenance logs, but all of it remains underutilized since all this data is in different silos. Instead of being leveraged for decision making, it's often scattered across systems, stored in silos, or it is lost over time. Efficient data use means using insights for predictive maintenance, better design, and continuous improvement. The future lies in connected data ecosystems where digital twins, AI, and analytics can turn all this raw information that we have collected, that we have, into real business value. To summarize these 4 points, these challenges, cost overruns, disconnected workflows, rework, inefficient data use, they're all interconnected. They reflect the need for greater integration, collaboration, and digital transformation. Addressing them is not just about a technology, it's about changing how teams work together across the entire life cycle of a project, from concept to operation. Now, even though we have the case that we have to adopt digital transformation, right? There are still barriers for us to address, to overcome. So even though we have clear benefits, this transition to intelligent construction isn't smooth. It's not so very easy, and it's not happening at the pace that we want it to happen, because every transformation faces resistance. Let's look at what's holding construction back. The common challenges that we have: cost perception. Upfront tech costs overshadow long term savings. And this has been a long term issue with the industry, right? And when we review very many of our projects, what we find out till it is adopted on a large scale, it still remains a little bit prohibitive sometimes to adopt technology. But the overall benefits that we can gain, right, overcome the cost that we incur for projects. My second major the second major challenge is basically the cultural resistance. And why this cultural resistance, right? Project managers always have fear of change, loss of control, right? There is a lot of resistance, not only to the change, but also to data sharing. We have all information in data silos, where there is a lack of interoperability between platforms. That means all systems are disconnected. There is no system that is talking to the other. And finally, we have a skills gap. The digital literacy lags much behind the pace of technology. So even though we have technology adoption, to adopt the technology, we still have a lot of gap to cover in terms of educating the, the people who are going to use this technology. So, however, so the biggest barrier isn't the technology, it is the trust. It has to be emphasized that AI's biggest barrier is cultural, not technical. In short, our industry doesn't need more tools, it needs more trust. Data silos, lack of standardization, and fear of sharing are stifling innovation. Participants in the workshop at Construction Bytes agreed that data sharing should be reframed as an ethical responsibility, similar to knowledge sharing in medicine, because sharing lessons saves time, money, and sometimes even life. As one workshop participant put it, your secret sauce isn't that different from mine. Share everything. What it means is that all of us are actually following more or less the same process and systems. So it's not difficult for us to share it across the industry within the stakeholders who are using it. So when we talk digital, we'll always have to come how this evolution is happening, right? The foundation of the evolution. And I think the first evolution is basically going in from 2D to 3D. So BIM, the building information model today is a bedrock of digital construction, the framework that makes data intelligent. It is where digital really begins. It really starts from a BIM model, the single source of truth for the modern construction ecosystem. Why BIM matters? We are not no longer drawing lines or drawing geometry. We are moving from lines to information, from drawing geometry to modeling information. Therefore, the name also, right, is a building information model. It helps to improve collaboration, coordination, enables clash detection, design coordination, validation, and of course, as we spoke before, integrated collaboration. This forms the base from the if we incorporate time, 4D, incorporate cost, 5D, and of course 6D of sustainability integration within the model. Why we need to talk about BIM? Because standardization and interoperability are the top rated needs for the construction industry. Without common data taxonomies, what I mean is data hierarchy or naming systems, the way that we talk, artificial intelligence cannot scale. Even defining what constitutes a building can differ across organizations. Artificial intelligence thrives on standardized, interoperable data. The white paper that I spoke about earlier it has noted. The construction industry still lacks consensus on basic definitions and data taxonomies. A building information model is what starts to provide the structure that can make AI scalable. BIM solves this by creating a single source of truth, a consistent data language that both humans and machines can understand and therefore interact with each other. When a BIM model captures every material, cost, and sequence, AI can analyze hundreds of variables simultaneously to find optimization opportunities. For example, In a 40-story mixed-use tower, BIM-based clash detection identified 1,200 potential design conflicts, all of which were resolved even before the first concrete was poured. The first step, generating a BIM model. And of course, the second step is turning reality into intelligence. That means bringing the reality into the models. Now, when we talk about scanning and creating BIM models, the scan to BIM bridges the gap between the physical and the digital world. It captures the real world as built environment and converts it into a digital twin of reality. Core advantages of this: firstly, captures exact as-built conditions. It reduces your site visits and reworks. You can preserve the heritage of the structure because it enables precise retrofit and maintenance planning. Uh, the as-built model can help in construction verification, helps in quality control, and of course, having all this information built into the same model, it improves the facility management post handover. The workshop, again, referring back to what I was talking about earlier, it proposed the creation of benchmark data set, anonymized. That means you don't know from where the data is coming, but this high quality reality data, which can be used to train AI for predictive quality control. It can be trained for safety monitoring and of course for maintenance optimization. Every scan, every drone flight, every site capture contributes to a smarter collective model of how we build. Scan to BIM turns reality into structured data, and that data becomes the raw material for intelligence. So, reality capture is not just about documentation, it's the foundation of continuous learning. Coming to the AI powered digital insights, which is the new brain of construction, if I can call it that. So we are adding this intelligence layer, artificial intelligence. And it's really the analytical brain that makes sense of the data generated by BIM, sensors, or by any other source where we are capturing data digitally. Okay. And we already have applications which is being actioned through this AI powered insights. So we've got autom- one automated documentation and compliance check. We have progress tracking from 360-degree imagery, detecting safety violations in site footage, uh, forecasting material demands and labor needs. There is predictive quality control to flag early deviations. And of course, the compliance reporting, as I mentioned earlier. Again, referring back to the workshop, the top AI use cases that they had was, which we are very close to, is the project document generation. What I've not spoken about is the knowledge capture and transferring this knowledge to other projects, to other stakeholders. Predictive quality control can optimize the supply chain. You can forecast resources. There is a tracking of sustainability. You can do analysis of workflow efficiencies. You can coordinate between shared logistics. Now, each of these actually deliver measurable ROI, saving time, reducing work, and freeing professionals for higher value tasks. On one pilot project, AI was used to analyze project photos daily. It automatically flagged around more than 200 quality deviations per month that human inspectors missed. Together, this could reduce project delays by at least 30% and rework by more than 25%. But let me make it clear, AI doesn't replace expertise, it enhances it. It allows professionals to focus on creativity and problem solving and not generally on the paperwork that they are generally doing. And then coming on to digital twins, which the connected future, which I would term as the living asset. Okay. The digital twin is the ultimate conversions of AI, BIM, and IoT. Everything I've said so far. A living, breathing replica of a physical asset. What are its capabilities? If I just to name a few, one is predictive maintenance, energy optimization, life cycle performance tracking, dynamic cost, carbon, need of the hour, and utilization modeling. And of course, there is this continuous feedback between the design and operation. Looking ahead, digital twins are envisioned as a part of autonomous, self-optimizing systems, capable of real-time resource allocation, supply chain management, and safety interventions. These twins will not just mirror reality, they will actively manage it. In a decade, every major infrastructure asset will have a living digital twin that not only tracks what's happening, but will predict what will happen next. The outline of the medium and long term vision of bringing artificial intelligence into the construction industry. Within the next 2 to 5 years, we will have integrated data platforms, predictive analytics, and of course, AI powered compliance. Going beyond five, I believe that we will have autonomous construction systems. We'll have full scale digital twin integration and real time optimization of materials, labor, and logistics. Just to have another example, there was a pilot project with an airport where the digital twin analytics cut HVAC energy use by nearly 18%. And it also improved the passenger comfort, which everyone can see. It's an immediate operational as well as a sustainability win. So all these technologies that we spoke about, AI, BIM, and digital twins, converge into what we at Incus Technology call the observance ecosystem. And I'm not going into specific aspects of what the system delivers, but the core features and key components, which I believe have to be a component of every system that is developed. The number one thing comes the collaboration through shared platforms. That means real-time cross-discipline coordination, open interoperable systems that connects all stakeholders. Second will be transparency, data trust, end-to-end visibility across project performance, frameworks to share data securely while also respecting the privacy of the data and also taking into cognizance the competition. Measurement. Again, I'm not talking about measurement of models. I'm talking about clear KPIs, reduction in rework, as we discussed before, 25 to 30%, delays, 20 to 25%, cost overruns, up to 15%. And if you combine all of this with schedule accuracy and energy savings, definitely, you have clear KPIs that define the success of getting AI into the construction industry. Number four, sustainability. We have lower emissions, travel is reduced, paperwork is reduced, and waste is also reduced through data-driven decisions. Right? We are one of the most what do you call maximum contributors of carbon to the carbon footprint. Every little that we do can help in building the sustainability, and of course, cultural change, continuous learning, and ethical responsibility in AI use. I believe that this has to be the key components when we are talking about features of an ecosystem that is using AI in construction. To sustain this transformation, of course, following will be an outline of a roadmap for the next maybe 5 to 10 years. In the short term, we will have pilot projects to show the AI use cases. And of course, all of this will be with measurable ROI. In the medium term, we look at a federated data governance framework. right? It's something that is going to be very well orchestrated. To achieve this, maybe we need a national data consortium of, of the AEC, the architects, engineers, and contractors coming together. We would have to have shared KPIs for digital adoption and data quality. We will need targeted upskilling programs to close what I was mentioning before as a digital literacy gap. So this is going to be in the medium term. I think the medium term is closer than we think that we are. It will be much closer than what I'm saying medium term. Maybe in the next few months to a year is when we will be coming. And of course, as a long-term transformation, it's going to be to develop autonomous AI-driven construction systems powered by digital twins. To get there, technology alone is not enough. Right? We need leadership, we need ethics, and overall, our culture must also evolve to achieve these goals. The cultural imperatives for this data sharing is an ethical responsibility. AI should augment, it's not going to replace human expertise. Right? It is always going to enhance the deliverables that we have. Change must be gradual, with small wins that build trust. As one participant said beautifully, the future of construction is collaborative. It starts with how we use our data together. I would like to make a few closing statements before I close this discourse because I really want to open for question and answers. I think it's a very large topic and there would be quite a questions in this group. So the future of construction is not going to be built by brick, cement, and steel, right? It will be built by data, collaboration, and intelligence, where AI will give us the foresight. Uh, Platforms like BIM will give us structure, and the digital twins will give us connection. But for all this, it is the people who will give all of what I've said here a purpose. We are not just going to build smarter projects. What we are trying to do is to build a smarter industry and a more sustainable future. With that, I will open this forum for questions for the audience. Thank you so much for listening in. Please let me know any questions that you may have.
Thank you so much, Anto sir, for this insightful session. There was a lot of great perspective on how AI, BIM, and digital twins are reshaping the way we plan, build, and manage projects. Now we would love to hear all of you. So we'll move to the Q&A session. And if you haven't already, so please drop your questions in the chat box. So we'll take them one by one. So now we'll move to the Q&A session. Okay. So we'll just see the questions in the chat box. So we'll answer one by one. If anyone have any question, please you can raise your hand also, so I can unmute you so that you can ask directly to us, Antos. Okay. So there are some questions out there. The first question is, Cantum might give us a correct geometry, but how do we reach from just 3D model, as built site condition to digital twin? There is one question from one of our participants called Parchit. Prachit. Sorry.
Okay. Left.
Yes.
So when we talk, sorry, this is my
One word. So
yeah.
yeah.
Okay. So when we talk about scan to bin, right? So it's giving you the correct geometry. We have solutions now which are actually segmenting this, and it is taking all of the elements that you can see in the geometry to a BIM classified. So all the elements in a BIM model can be classified and segmented in this what is that called, in the model that we are generating from scan to BIM, right? So it is not just a 3D model; it is an actually as built BIM model, right? But we are depending on the exact dimensions that we are generating from site. The only thing that what we needs to be done manually is that we are putting the asset information into this model so that it can be given on to facility managers to help them to manage their operations, right? So so this is what we are talking about now, is that just not a 3D model scan to BIM, it's a proper segmented model that goes uh, that is a proper segmented BIM model that we get, right? So it's a real digital twin. We are not talking about just a model. We are talking about actual digital twins now. That's the technology that's available in the market, also available with us.
Okay, sir. The next question is it is from Abhinasri Samadam. What process the standards like ISO 19650 support the shift from BIM to digital twin? Can you please mention what are the main software used in this industry?
So when we are talking about the things like ISO, etc., there is a committee that is formed by the Indian government from the IS code section, who are sitting together and reframing a whole document that defines how a BIM and a digital twin needs to be, what are the rules and regulations, what are the aspects that need to be considered. So they are in the process of releasing an IS code which will define the BIM and digital twin requirement, right? Can you please mention what are the main software used in the industry? I think, so there is a lot of software that enables conversions, at least of as-built models to from the as-built construction to the BIM models. It's basically dependent on different. This thing is basically dependent on the type of hardware that is being used and the type of output that you want. So there are systems that that gather point cloud data through lidar processes, and what happens is that basically there are some of us, like like inkers, we can do this automatically by changing point cloud to a mesh, to creating, to segmenting it, to going to the BIM model. But there are other software also that goes in and what you call manually looks at this point cloud data and then transforms it to a digital twin. So it's done two ways. One is a manual process, takes a little more time. One is, of course, some automated processes, and I'm sure that there will be other organizations that also catch up with us in this process. At, I'm reading the question. So, at
At
what
what
stage
stage does
does
observance?
observance
There is a question from Chaitanya. At what stage does observance come in while executing the project? What is AI being currently used in our observance?
So at what stage comes in? So observance can be used. See, so the way that is done is our products are actually we have a component that is doing on the design management stage. We have got products that are being used during the construction stage, and of course that as-built model is going on to the facility management. But really speaking, observance and the true value is coming right at the beginning of the project when you start your on-ground construction, because then it helps to capture every detail throughout the life cycle of this construction. So you get a whole history of what has been done at at the site. What AI is being used. So, AI, when we talk about, I don't know whether it's a very misused term also, because it's very difficult. It's, sometimes it's very much abused, I think, the word AI. But what is being used, there are a lot of algorithms that come into play for, like I said, for converting the point cloud to the mesh, for converting it to for segmenting it into the BIM model classifications, etc. We are using computer vision to check out for defects, uh, for quality issues, general quality issues, what you can see. We are using some other what do you call uh, software for analyzing the schedules and the bill of quantities that are generated. Bill of quantities, of course, come when the bill is generated. So these are all the types of software. That's all the type of platforms or the AI that is being used into the platform in observance. Can scan to BIM be extended beyond geometric reconstruction to also extract labor, equipment, and material productivity metrics with integrated digital twin models? So we are in the process of actually capturing this, right? But yes, when we combine all of the information that we are gathering from the site, right? We are using some of the project sites use cameras to calculate the data inflows, etc. That is coming into the site, so you know exactly which labor has entered the site, and of course, because we are able to extract quantities from the platform, we are able to relate that to provide labor productivity metrics, right? The same system can also be used for material productivity metrics. Equipment, not so much, because it definitely depends on the type of usage. But we are in the process of expanding this platform to also capture the equipment metrics with digital twin models. So yes, these are already being extended. It's not can scan to BIM workflows be extended. Scan to BIM workflows have already been extended to capture the metrics that you have stated. How to overcome the resistance from project teams when we propose this solution? Actually, from all these questions, this is the most difficult one. How to overcome resistance, right? Because I come from a project management background with over 40 years in this industry, or not over, nearly 40 years in the industry. So it's basically a cultural shift, and that was something that I was trying to stress when I was talking about this whole AI revolution. Uh, the first thing is to make people at the bottom. See, when you go and we pitch in organization, management fully understands that we have to transform ourselves, we have to get all the latest technology. The resistance is actually at the very lower level, where people are afraid that we will lose jobs, etc. So there's a great deal of culture transformation that needs to happen at the from the management, training their people that this AI is not about losing jobs. It's not about eliminating resources. It's about enhancing your skill sets, right? So whatever you do today, you will be able to do much better. You will be able to do it over more wider projects. So I think there is a lot of cultural transition or training that needs to happen at the bottom level. Uh, Inherently, a project site, and since I've grown through this whole process, is that we are very, we don't share data. We don't like to expose ourselves. But once we realize that, like I said, data sharing should be an ethical responsibility, and this is a culture shift that we are looking. Once we are get used to this idea that sharing data is only going to help me to perform or to do my work better, I think that is what is going to, really overcome the resistance that we face. We don't have resistance from management; it's actually the end user. Unfortunately, in our this thing, the management is not the user of the intelligence, right? The intelligence used at the bottom, but the management is driving it. So I think management has to spend more time on changing the culture at the bottom. So is BIM models worth cost-wise and benefits-wise only for large projects? How can it benefit me in villa projects of 2,000 to 2,000 square feet in size? See, once you start adopting BIM, right, and even if it's a small project, Uh, of course, the cost of a BIM for a small project will be larger, because basically when we do for large projects, there is a lot of repetitive work which spreads across. So when we have typical flows, you are just replicating a BIM model flow by flow, and even so, when you spread that cost over this large square foot area, it does fall cheaper. It will be more expensive from the from compared to a villa project. But now the thing is that you cannot look at the cost of the BIM in isolation. We spoke about, at least I spoke about in the discourse, that we have got nearly around 20 to 30% loss in reworks. We've got around 15 to 20% delays in construction. Now, if you try to add all of this together, right, you will again save on even on a small project, right? Because you will be able to envision your building in its full form, in exactly what you are going to get. You can make changes that you want to before you even build it. So the so even if you take a villa, right, it is going to be beneficial. You will not get as much benefit as we get from a large project because the costs are a little bit cheaper, but definitely the benefits, and especially for a small villa, right, where lot of inputs are required from the owner of that villa, and you will, you know, and I've come across, we've built, multiple villas where the owner will come at the end and say, I want to change here, I want to change this, I want to fit my fridge in so and so place, I want my puja room in one place, and all of this leads to rework and change, which is much more higher as compared to a bigger construction. The next, there is still a gap between construction space and the facility management space in terms of information. Can you please advise how this gap can be reduced or removed? Hey, hi, Sneha. Yes, that gap. That gap, I think, people are working on it quite a bit. When I've been with the Autodesk people, we've been always talking about creating this unified platform. But I believe that eventually this is going to be driven by the industry to reduce this gap. Right now, like I was saying, uh, we can get asset information between the BIM model. It still needs that integration to an integrated facility management platform. So there are certain amount of tasks. The adoption of this digital twin, it's become just like as an information center. It's not really stitched into the predictive maintenance, etc. But I believe that the way the AI, the way technology has been progressing, uh, definitely within the very near future, maybe less than a year, we will see this gap being reduced. Right now, yes, there is no platform that actually stitches the as-built model to the for the facility management. What short-term actions or collaborations are needed to begin standardizing data formats across the construction industry? I think I touched upon this also, right? If the first step is going into BIM adoption, because that is actually standardizing the way we call data. It is a common language between humans and machines. And unless we have that common language, unless we speak a language that machines can understand, yeah, so that is going to be always a challenge. So I think the first action is develop using a BIM model for your construction so that the data can be stored and analyzed. There is one last question. I've just got 3 minutes, so I'll just take that last one. What are the biggest cost drivers in a scan to BIM project, and how can they be optimized? The biggest cost drivers is basically the equipment that we are taking in. Today when we talk about computing costs, that's still high. There's a lot of computing that goes in. Uh, how it can be optimized? Everything is depending on scale, right? The more people adopt this, as the scale increases, I think the cost will come down. Yeah. I think I'm just running short of time, so I'll hand it back to Ravi. Ravi, over to you.
Okay, thank you, Anda sir. Thank you everyone for being such a wonderful and engaging audience today. We hope this session gave you a clear picture of how emerging technologies were enabling for smarter, faster, and more connected construction workflows. A big thank you again for Mr. Antav sir for sharing his time and expertise with us. Before we wrap up, we'll receive the session recording on your digital email ID. And yeah, on behalf of entire team of Interest Technology, thank you for joining us. Have a great day ahead, and we look forward to seeing you in future sessions.
Yeah. Thank you, everyone.